Hello, my name is Carolina and I'm here for another experimental demo.
Yes, and this one is going to be on determining the specific heat of a metal. And what we're going to do, as explained earlier, is to take a hot metal and put it in room temperature water, see how much the water temperature is raised so that we can determine the specific heat. Now, what we have here is a heater. We have a calorimeter, which is made from two foam cups nestled within each other. And we have a graduated cylinder with 220 milliliters of water in it, which is 220 grams. And some miscellaneous equipment like a thermometer and forceps. So the first thing we're going to do is we're going to weigh the empty calorimeter. And we're going to determine what that is.
9.88 grams.
9.88 grams. Now we're going to take the empty calorimeter and we're going to pour all of the 220 milliliters or grams of water in there. And just for the fun of it, let's weigh that. This is the calorimeter plus the water.
226.29 grams.
It seems like we lost a little, but probably in the vessels themselves. So what we would do to determine the mass of the water is to subtract the weight of the calorimeter, or mass of the calorimeter, and we'd get the mass of the water, however you want to do that. Okay, now what we're going to do, we're going to put the calorimeter down on the counter, and we are going to take water that has been heated to 100 degrees Celsius. It's to the boiling point. We're going to take this piece of metal and we're going to put it into the calorimeter. Not the, yeah, we have to measure the initial temperature, thank you. And we're going to see the initial temperature of the water in the calorimeter is how much?
It is 24 degrees Celsius.
24 degrees Celsius. And so now what we're going to do is put the piece of metal in there. We're putting hot metal, copper it is. It is a piece of copper. And we'll be getting the mass of the copper in a little while, but we're going to let that stir around with that. And we're going to let the copper transmit its heat to the water. And copper is a good conductor, so it will do that fairly fast. That's why the bottoms of most good pans are made out of copper, because it's such a good conductor of electricity. And then we're going to see what the new temperature, the final temperature is.
Still moving, so.
Oh, it's still moving. Okay, that's good. I once burned myself with a copper penny, you know that?
Really?
Yeah, I had a 9-volt battery in my pocket and I put some change in there and the copper penny got across the two terminals of a 9-volt radio battery. And it was hot. When I put my hand in my pocket, I burned my finger. All with a 9-volt battery and a penny. That's all it took. And we're looking to see what the new temperature is going to be.
It's a little bit under 30.
Was it 29 and something?
Yeah, about 29.
Let's say 29. Okay. Now let's weigh the whole thing without the thermometer so that we can subtract the weight of the water and the calorimeter from this weight that we're going to get so that we get the mass of, I should say mass, of the copper. And what do we have now?
250.37.
250.37. Now, what you are going to do at home is you're going to use these figures and complete the data table that is in this exercise, and you're going to come out with the heat, the specific heat of copper. And you can look it up on the internet and see how close you come and see how far off you were. And I'm going to ask you to list the reasons that you may not be accurate. So, thank you for viewing the demo and submitting the results.